Hello, everybody. Thank you so much for joining us for today's webinar. We are so excited to hop into sustainable spectroscopy. While you're kind of getting settled in, I'd encourage you to go grab a beverage, get comfortable. Also, go ahead and take a look at your Zoom window. On the bottom of the Zoom window, you'll see what looks like a little chat bubble. If you click that, you'll be able to populate our webinar chat. That's where we will be taking questions today. So if you have a question, pop it in there. An important thing to note is that in that chat bubble at the bottom, it'll say to and then allow you to select to whom you're typing. Make sure that to section is set to everyone. We ask that for two important reasons. One, when you ask your questions, we want everyone to be able to see your questions so that we are participating in knowledge sharing. Other people are probably wondering the same things that you're wondering. Other people might have been thinking the same things you're thinking. So make sure other people see that we've all got the questions, and set that to everyone. Also, when we answer your questions, we don't want to look like we're talking to ourselves. So we ask that you please set it to everyone so that they understand why we're saying something. To practice that skill, go ahead and in that chat box, drop in there and let me know. Let's see. What is the very first thing you do during back to school? And I mean, like when you open your classroom door, are you decorating? Are you cleaning? Are you brushing off your Vernier sensors? What is that first thing you do? Oh my gosh. David says crying.
Stub my toe.
Stub
Cry.
my toe. Cleaning glassware, fair. Unpacking 3D printer, very cool. I know we have a Thingiverse where you can find different things you can print to help with Vernier sensors. Let's see, dusting and cleaning tables and chairs, coffee, coffee, coffee. I totally hear you.
Coffee. That's
Yeah.
probably my first thing.
Chris shares arranging and cleaning. Hey, Chris, good to see you. Annette says locate missing furniture. Reconnecting with colleagues. Yes, that is the best part of back to school. See what shape my room is in after summer rentals. Clean my classroom. Unpacking. Yep. Oh, hey. Kevin says ordering Vernier sensors. Go, Kevin.
Thank you.
Thank you. All right, my friends, we are about a minute past the hour, and I do want to make sure we have plenty of time for our presenters today, so I will hop into some housekeeping items. Do you want to go ahead and share the deck, Noose?
Sure.
Awesome. And while Noose is pulling that up, I did want to let you all know we'll be doing a giveaway at the end of today's webinar. It's only open to people who hang out with us to the end of the webinar, so make sure you stick with us. We're giving away $100 towards Vernier, so you may be able to get that sensor you've been looking at. Really good stuff. And right now, statistically, you're in a great spot. All right, let's take a look at that housekeeping items list. Perfect. As always, you will get a recording of today's webinar. It usually takes us about 3 to 5 business days to get that edited, but as soon as it's live, we're going to put it on both our YouTube channel and our website. They're both linked there. You are also going to receive an email with that recording link. In that email, you're also going to get a resources folder. As soon as I'm done chatting, I'm going to drop a link to that resources folder in the chat. In that folder, you can see both this presentation with clickable links. You can get a certificate of attendance, Noose drops some experiment files in there, and a few other goodies. So make sure you take a look at that. And as I said right at the beginning of today's webinar, we would love to answer your questions. So please drop your questions in the chat. We're going to be here hanging out, making sure we get to those. If we happen to not answer your question or you think of something later today or tomorrow, please feel free to reach out to us. You'll probably get one of these two folks here. And you can email us at chemistry@vernier.com. With that being said, I am done, and I will see you at the end for the giveaway, and I'll pass it off to Noose and Melissa. Thanks, everyone.
All right. Hi, folks. My name is Nüs Hisim. You've got the whole Vernier chemistry department here for this webinar. I taught in Maryland for 34 years, chemistry and physics, used Vernier equipment since the early 80s. And so it's a lot of fun now to be able to turn that around and share that with you all. Melissa, did you want to say something about yourself?
Hi, everyone. I'm Melissa. I'm also one of the chemists at Vernier, and I will be furiously answering all of your questions. So definitely throw them in the chat. Check out the resources folder. And I am not afraid to interrupt Nüs. So definitely put your questions in the chat. I'll interrupt Nüs or answer there when appropriate. So,
Sounds good.
yeah.
All right, let's take a look. A couple of things to be aware of. We're going to be using spectral analysis tonight. Wonderful piece of software, free. Runs on anything, computers, Chromebooks, phones. I used my phone this afternoon to set up some of the solutions that we're looking at. Tablets, so it runs. It's just kind of a nice piece of software. And then I think Devin already shared the folder with you. We have a bunch of files and student files and stuff like that we'll share with you, so you can try this on your own if you want. Um, Melissa's going to talk a lot more about green chem at the end, but one of the things to consider here, I've been doing this for a while, and I built my first colorimeters way back in the 80s and early 90s. And I was doing, Beer's Law with copper sulfate and nickel nitrate, and not, crystal violet for kinetics. And, when you look up the STSs on those, boy, some of that stuff should be going down the drain, and you should be probably, I was really nonchalant a little bit with my students about how they handled stuff. I tried not to be. They wore goggles and whatever, but there are wonderful options that involve things like food dye that don't change what the students see. And you'll see that tonight. And you get the same results, and you can avoid a lot of those hazardous situations and so forth. So what we're going to do is, I've been doing Beer's Law forever, and when you're doing it with food dye, there's a small adjustment you need to make. Usually when you're setting up a stock solution, you'll weigh out something and, 1 liter and you've got it. But when you're using food dyes, there's a couple of ways to do that. And so I'm going to show you what I think is the easiest way. The activity looks at the relationship of percent T to absorbance. So those of you that are AP Chem teachers, experiment number 1, sports drink experiment, very similar. But Melissa did a nice job. She kind of took that and melded it nicely with Beer's Law. We get a lot of discussion. It's like, why aren't you doing Beer's Law for experiment 1? Well, because College Board has that in experiment 2, the copper and brass experiment. So the idea with experiment 1 is, what's the relationship? So we did a nice job of, I think, let's see what you guys think when we do it. And tonight I'm going to use SpectroVis. I've had questions about, can you do it with a colorimeter? Not what we're going to be doing tonight. It's going to be hard. So here's a potential icebreaker, I don't know, topic you could bring up with your students, okay? From this activity, you will determine the concentration of blue food dye. Question to the students, well, if you knew the concentration, then how would you find the mass of the dye that you drank in a 16-ounce bottle of sports drink? And I've got a couple of them here that we're going to analyze. And there's more to it than that, but you might, have the kids get the juices flowing, what are we going to use this for? How many times have you heard that in your career? So let's do an experiment. Okay, now before I do an experiment, we need to set up a solution. So let me bring the experiment up so you guys can see it. This is the experiment that Melissa wrote. And like I said, it's kind of a combination of Beer's Law and sports drink. And so you'll see both of those. And what you're going to need for this is you're going to need a stock solution of blue food color. Okay, so the kids, that has to go to the students. You're going to need to create a bottle, or however you do it in your classroom, of stock solution. And so I'm going to do that first. And then what we're going to do is we're going to walk through kind of, the most important parts of the experiment. I won't belabor everything because you guys can do this. But let's go ahead and make the stock solution first. So how do you make the stock solution? What you need to do, first thing when you're going to make it, is how much do you need? Okay, so if you look at the experiment, the students are going to be making dilutions, 10 milliliter dilutions of the stock solution. And so, what mass of stock solution are they going to, or volume of stock solution are they going to need? Well, it comes out to be around 35, 34 grams, something like that. A mile grams. I don't know why I've got mass stuck in my brain, because I read that earlier, I think. Milliliters. So, plan on maybe 50 milliliters per lab group. Okay, and so then when you go to set up your solution, think that through. How many lab groups do you have? You want a little bit for spill. Folks, it's blue, it's food color. Who cares if you make up too much? Make up a liter, it's not gonna matter, right? So what you wanna do is get some water. If you can get it spinning, it's a little bit more helpful. And what we're gonna do is I'm gonna put a couple of drops in there. I get this all the time. How many drops? It's usually around 2 or 3 per 300 milliliters, but there's a more important consideration. So let's look at that. And so what I'm gonna do is I'm going to use my SpectroVis to determine the concentration of the blue food color. Yeah, we're cheating. We're doing what the kids are gonna figure out later, okay? So let me get the SpectroVis up here. So I've already got it connected by Bluetooth to this computer. It could connect by USB if you need. Why does it say connect the spectrometer? That's annoying. It should have been connected. I must have bumped something while I was fooling around. Hopefully it'll connect. If not, I'll plug it in. Beauty is that all of our Go Direct sensors, you can plug them in by USB if, the Bluetooth. Sometimes Bluetooth can be a little wonky. What we're gonna do, now remember, this is you the night before. You're making the solution for your students. What you want is a solution that's going to absorb at around 0.9 relative absorbance units. And the reason is, now this is us looking at this from the teacher point of view, this middle part of the graph here is what we're after in terms of collecting data. If the absorbance is too high, then the transmittance is hardly happening at all. If the absorbance is too low, too much light's coming in through the solution. So we recommend 0.1 to 1 relative absorbance reading for solutions where you're going to do a lot of stuff quantitatively. So what I'm going to do is I'm going to just measure the absorbance of this blue food color that I'm setting up for tomorrow's experiment. Now, this guy was on, to save this time right here, I already went through and calibrated it, and then of course you saw somehow I bumped a button or something like that. So I am going to skip the total warm-up time because I know this thing was on. I turned it on at 3:30 and I was fiddling around with it. So what I'm gonna do though, I will need a blank, and so the blank in this case will just be water. So I'll put some water in here. We want the light to travel. Light does travel through the bottom of the cuvette, so we want to make sure that we fill it at least 3/4 full or something to make sure. I'm going to give it a little wipe there. And what's nice is the software now tells you everything. Right there it says, we don't even put these instructions in our most current lab instructions for students even, because just follow the directions on the screen. It tells them what to do. So the blank is in there, so I'm going to hit finish calibration. The Go Direct SpectroVis is good for 380 to 950 nanometers. Usually when you're starting to bump the ends, you're looking at emission spectra, like you can put a fiber on here and measure the emission from remote controls that put out infrared light. But anyway, let's get back to our prep. So we've calibrated the spectrometer. I'm going to take a sample of the solution that I want to give to my students tomorrow, and what I want is I want it to absorb at around 0.9-ish. So let's take a look and see. So I'm prepping for tomorrow, right? That's the whole point of this. And it's a little high, okay? So I'm gonna need to dilute that. The nice thing about this is, think about it, folks, it's food dye. It's not like, we're not talking about a very expensive thing here. It's a little fiddly. You can, if you are a purist, you can buy, where did I put that cube? There we go. You can buy the food dyes. Flynn sells a set of all 7 of them in powder format, and that literally a lifetime supply. But if you're going to do what I'm doing now and you want to weigh it, you're going to need an analytical balance, and honestly, 1/10 of a milligram at bare minimum, to get good data. So there, look at that. His Nüs is pretty close. That'll be fine. That'll give us good data. Okay, so I kind of looked out there. That's kind of cool. So what I would do is now I would put this in a stock bottle for the students. Okay, your job is done. Okay, so now let's go over to the student side of the experiment and see what they're supposed to do. So what they have to do, they have to prepare some dilutions. And so all of these, now what I did was, Melissa and I practiced this, Dylan was in on it too. And I have a pipette, and I was making them all the other day, and I realized it's gonna take too long to do that during the webinar. So I made them up already, all of these. Of course, students would have to calculate the concentrations, because they're gonna need those later on. And then I even put them in cuvettes, labeled cuvettes, just to save us the trouble of having to do that. But in the first part of the experiment, you're actually going to use an option in spectral analysis that's not that common, and it's kind of cool. It's a neat option. So I'm going to go back to spectral. I'm happy here. This is good. I've got this. I skipped this one thing. I need to know what the concentration of the stock solution is. I'm not weighing out the solute, so I need to know the concentration. So I need to know that value at the peak. Okay, so at the peak, my solution is absorbing at 1.02, 1.019, and so the easiest way to figure out what the concentration is, folks, is to cheat. Okay, use Beer's law, what you're trying to teach your kids. So if we do that, okay, let me make this ever so slightly bigger so you guys can see what I'm doing. These are the molar absorptivity constants. These are the slopes that you get when you plot Beer's law. So these are the molar absorptivity constants for the common food dyes, and I put crystal violet in here too. And what I did, and I'm not a good spreadsheet person, so if you want to take this, it's in the shared folder. If you want to take this and make it pretty and a little better, like what right now, if you want to do any other color, there's no reason you couldn't do other colors. You'll have to change the molar absorptivity value here, because I'm not smart enough to know how to make it automatically do that. But you do need to put in your absorbance value from the spectrometer. So what we say, 1.2, 1.018. All right, let's call it that. So you put that in, 1.018, and there is the concentration. And to save you a little bit of time, you're welcome, I have it calculate all the concentrations that are on that sheet, at the beginning, the intro that the students have to. We're going to need that later on anyway. So when you do your stock bottle, you're going to need to put that. The kids are going to need to know what that value is. So 7.83 times 10 to the minus 6, that's going to have to be on here so kids can know what to use when they do M1, V1, M2, V2. But let's get back to the student side of things. So the students are going to look at the transmittance, and they're going to compare that to the absorbance. This is a I would say a good hunk of students will have no idea what you're talking about. Okay, so let's see how you can do it in spectral analysis. So the kids would start out fresh. They would type in spectralanalysis.app, or if you have it installed, if you're doing it on your phone or something like that, you have to have the installer. But if you're on a computer, Chromebook, or an Android device, you can run it through the web, and it's kind of nice to be able to do that. This one, I don't know, I'm getting a little suspicious on this guy, because he keeps dropping off, and he really, I did start it from scratch, that's right. Okay, I didn't just do a whole new experiment, I did a whole new web page, so that's why it dropped it off. So probably gonna make me go through the whole calibration thing again, so let me put this cuvette out of the way temporarily. But what I'm going to do this time is I'm going to go down to advanced full spectrum. And you'll see why. There's a good reason why. You can see absorbance and transmittance are up here, but if we're going to compare them, this is a wonderful way to do it. So the experiment says start with transmittance. So I'm going to go over here and change the mode to transmittance. By the way, look at all the things the Go Direct SpectroVis can do. It's pretty amazing, okay? But I'm going to change it to transmittance, and I'm going to hit collect, and it's making me go through the calibration, that was my fault because I restarted the app, and so it disconnected from the sensor. That wasn't, I can't blame that on the software. That was Nüs's fault. So it's been warmed up. Gonna go ahead and skip it when I can. Got the cuvette in there, so let's calibrate it. And then what it tells the students to do is take a sample of the stock solution and put it in the cuvette and measure the transmittance. Now, this is where you might have to get involved, okay? Because depending on the level of the students, understanding what the transmittance is could be a challenge. These things that we carry around right here on our faces, they are transmittance sensors. We can only see light that gets into those sensors. We can't see light that's absorbed. And so when you look at this, this is a strange looking graph because it looks upside down, and you can actually click on it a little bit and you can kind of get some values and you can say, oh, right in here, the transmittance is very low. In the kind of the yellowish orangey reddy part, and then way up here in the very red parts and way down here in the very blue parts, it seems like it transmits really well. Now, to some people, you might look at that and go, well, yeah, it's a blue solution. I'm telling you, for students, this will not be that obvious, okay? So now, what does it look like compared to absorbance? And this is, boy, this should open up a lot of discussion. If I click on the little star up here, I can change the mode to absorbance. And so I'll do that. The neat thing about this mode of data collection is that it allows a right axis. And so now you can see the absorbance is appearing over here. Same solution. If it needs a calibration, I could always redo it, but I don't think I'll need to. And now let's take a look at the absorbance graph. So we saw the transmittance. Now let's take a look at the absorbance. And so now what is going on? I mean, I would assume that your students, you usually stop data collection once things have kind of settled down. And so if I stop data collection, this is a great opportunity for students to kind of look around and go, those peaks, what's going on with those peaks? Or anti-peaks, if you want to call it. We were discussing in the lab, normally we talk about lambda max, but down here, this is kind of like lambda min, right? And so this is a great opportunity for kids to just kind of think about, and maybe help them out to try to go, why is one way and one the other? What is absorbent? What's being absorbed, right? The light in here is putting out a lot of white light. And so that white light is going into this blue solution, and what's coming out and what's not coming out. So absorbance is a nice measure of what's not coming out. Now, as far as reports go, students would be told, save the data. So depending on your platform, you go to the file menu up here top left corner and you would save the data. And this one, I'm going to put it on the desktop and I'm just going to call it part 1. Just so if we want to come back to it later, because I want to talk about reports and things, but I want to make sure that I get the whole experiment done. So isn't that kind of sweet? The way that they both appear on the same graph, even though they're two axes, and you could split them if there was some reason you wanted to. You could split them, but yeah, kind of a neat thing. Melissa, anything I need to know about so far? So
No. Yep, people are just excited. So
okay, so I've done the first part, and notice students should take note of lambda min and lambda max, and what's going on with those two, and then of course save the file. We're going to talk later about making reports, and I'll show you some tricks that we've kind of worked out as teachers. Go, oh, this would be a cool way to make a report. Now, what about the effect of of concentration on absorbance and transmittance, okay? What does it look like? If we change the concentration, how does that change the transmittance? How does that change the absorbance? You might even ask the students that question before you do it. They may be thinking, oh, it's going to be linear or it's not going to be linear. They may not have a clue, and that's okay too, because you're going to figure it out anyway. So I'm going to go back to Spectral. I saved that file, so I'm going to start a new experiment. And this time I'm going to go to transmittance first. And instead of doing a full spectrum, I'm going to do against the concentration. So all those test tubes that we set up earlier, we're going to look at how does the transmittance compare. So what we need to do first is we need to decide what wavelength. Oh, wavelength. Didn't we just talk about wavelength? Lambda mid and lambda whatever. So this is the stock solution still in the spectrophotometer. Students can click and find that min. They can also enter it. I had a teacher who wanted to just enter the value, and that's fine. But I think it's better to have the students decide, you know, why would you choose this one over another one? And so there we go, I like that. And now I'm gonna click done. And now what's happening is that's a live meter there. And I'm gonna make this ever so slightly bigger. When you're teaching, you might wanna take note of this app preferences option. Makes it a little easier for people to see what you're doing. So here is that spectrum that I just measured. Here is the transmittance at 626 nanometers. I'm gonna use the stuff that I already prepared earlier because this one is not the exact same solution. So, and then what the students have to do is they have to walk through all 8 of the test tubes and look at the transmittance data. So I'm gonna put in test tube number 1. So this is cuvette mark number 1. That's what was in test tube number 1. I've been handling these all day. Let me clear off some of my fingerprints. And then let me start collecting data. Now this one's a little different if you haven't done this before, because now there's another button, and the button is saying keep. So this is called events with entry data collection. And so what we're going to do is we're going to take note of the meter. When the meter stabilizes, we're going to click keep, and it's going to come up and say, what's the concentration? Now, this may or may not, you know, trigger something in your students, but didn't we do a pre-lab? Okay, so I did it for us. Here's the pre-lab, okay, that, you know, you may, or I wouldn't share this with the students, but the number, test tube number 1, 7.83 times 10 to the minus 6, so that's gonna be, you know, I just forgot that, 7.83, okay. So that's gonna be the value. With spectral and graphical, if you need to do an exponent, you hit the letter E, like you used to do on an old calculator, and then minus 6, and so then it will put that point on the graph. And so now take that out, test tube number 2. Once again, I'm watching this meter, and I'm waiting for it to stabilize. In the Vernier world, if a student makes a mistake, after collecting data, they can go back and change the data they put in. They can't change the data from a sensor. Okay, so test tube number 2, go back to the sheet. It's 6.26 times 10 to the minus 6. So now I'll have 2 points on the graph, and let's take that out to test tube number 3. So while that's stabilizing, I'm going to go back to the sheet and find that number, 4.70 times 10 to the minus 6. So 4.70 E minus 6. All right, take that one out, put in number 4. Let's go, while that's stabilizing, let's go see what number 4 is. Number 4 is 3.13 times 10 to the minus 6. And let's do number 5. See, what was number 5? Number 5, 2.35 times 10 to the minus 6. number 6, 1.57 times 10 to the minus 6. All right, almost there. 2 more. Number 7, 7.83 times 10 to the minus 7. 7.83 times 10 to the minus 7. Notice how high that value is. 7.83 e minus 7. And the last one is when you go back to the table, you see that it's just water. So I already made up a QVec for it, so I wouldn't have to fumble around. So notice that that's kind of a measure of your calibration too. Because, it's pure water, it should be around, once you calibrate it, the maximum amount of light that can pass through the solution would pass through the distilled water. So I'm off by around 1%, not too far off. So that one, the concentration is 0. And now I'm done. So the way it works now is you would click stop, and then a student would go, Mr. Hisim, I forgot to do another point. So if you hit collect, you get a couple of choices. If you do need to collect more data, you can append to your data set, which is the small word that they may not know the answer to, depending on their age, or there's this big green button that says, pick me, pick me. No. If you need to add more data, you need to append to your data set. Okay, and that's what you would do, and then you could add more data. The other thing I mentioned is once you stop collecting data, if you need to change anything, you can do it after you've collected data. Boy, isn't this annoying? Look at those numbers in decimal format. If you click on the 3 dots next to either title, you can go into the column options, and there is an option there to do scientific notation. And I don't like auto. I like two decimal points. I think that looks nice. And so then it'll look a little bit nicer, than it did, earlier. So if you need to adjust that, I have had a couple teachers like, what do I do with that? Now, the students need to look at this and kind of think about it, and you look at it and go, is it a line? Is it not a line? Okay, well, we can do a curve fit, and we can try and see how close to a line it is. And you can see that's not very linear. Okay, so the relationship is not linear, but we're going to do another part of the experiment where they can actually compare these. Let me put a title on my graph real quick so later when I'm doing a report it makes sense. Transmittance versus concentration, and then I'm going to save this one for now. Because we're gonna come back to it in a little bit. So let me go ahead, save that. This is part 2A. Desktop, yeah, there we go. Part 2A, because this is the transmittance side. You can call it anything you want. Now what I'm gonna do is I'm gonna repeat this, but this time instead of measuring the amount of light that passes through the solution, I'm gonna measure the amount of light that doesn't pass through the solution, the absorbance value. So I'm gonna start a new experiment. And I'm going to use absorbance versus concentration, which is what a lot of us are used to. But if you're trying to help the students understand the relationship between the two, then it's important that they get a chance to measure those. And so let me put the test tube number 1 back in so we can get the wavelength we want to use. And so this time, this is the lambda max that many of us are used to. By the way, if you insist on using copper sulfate, make sure you reduce that concentration to below 0.1 molar. Otherwise, it's going to peak out like crazy. All right, that's good. And so the same process as we did before. Notice the values for absorbance. So a lot of light is being absorbed by this solution. So let's go ahead and hit collect, and let me bang through these real quickly here. So you'd think I would memorize them, but of course it's slightly different. 7.83, okay. So let's go ahead and put that in there. And we'll get test tube number 2. Or cuvette number 2. Good spectroscopy hygiene, 6.26. remember that for me. Good spectroscopy hygiene, you should use the same cuvette. Rinse it. 6.26 was it? What happens is there's small differences in the optics, especially these plastic cuvettes. And so what students should be doing, in the test tubes, they've got 10 milliliters of solution. The cuvettes hold about 3.5. And so you've got plenty that you could just use one cuvette and you could just rinse it with a couple of aliquots of the solution before you actually make your measurement. You'll probably get slightly better data, but having said that, let's see how Nüs does on his Beer's Law plot. All right, so getting back here, this is test tube 3. That one is 4.70. All right. How's it going in the chat? Anything interesting? Anybody do Beer's Law?
Yeah, it seems like lots of people have some really good ideas around Beer's Law. Some people do them with different, looking at different colors and doing mixtures and things like that. So yeah, have had some pretty good questions.
Yeah, there's no reason you couldn't use all the colors. Now, interestingly, if you buy green from the grocery store, it's a mixture of blue and yellow. So you'll get 2 peaks when you're looking at, or 2 minimums. So another discussion point. The software does allow you to plot against both those peaks. You can have multiple peaks if you want. Number 5, 2.35. Okay. And so interesting, but you could have the kids in the class, 2.35, I'm talking and Melissa knows I'm going to forget something here. You could have them determine the amount of food dye in different soft drinks, so definitely kind of make it so that everybody's not doing exactly the same thing. Number 6, 1.57. If I forgot to put the exponent in, it would skew the data like crazy, but we could always go back and fix it. 7. Yeah, that first one, I remember the college board one. You had the kids looking at all kinds of different solutions to look at their spectra, and I don't know, just didn't, this is number 7, I'm talking and I'm forgetting. Number 7, 7.83 times 10 to the minus 7. I gotta be careful so I don't screw that up. One more, that's gonna be the blank. Can you do them the opposite order? Sure. You do them in any order you want. We're just plotting points here, so it doesn't really matter. Look at that absorbance, how low that is. I mean, of course, and I know it's logarithmic, so, but, it does look good. It's a very, very small value. All right, I'm done collecting data. So I hit stop, and then what I do here is similar to what I did before. How linear is the data? Let's find out. So I can go down here and I can do a curve fit and see. Linear data is a lot simpler to deal with. And so it's kind of it's what people like. Look at that, Nüs got 3 nines correlation. That's not bad. It's best value you can get for the correlation coefficient is 1. So, the more 9s you get, the more linear your data is. But that's a discussion for the students, is like, when they actually go and do the analysis for this, let me finish and save this. I'm going to show you a couple more things and I'm going to turn this over to Melissa. This one is what, absorbance versus concentration. And let me save this one, but I want to do one more thing that your students may or may not do in this order. This is part 2B. All right. So when they go to make a report, so let's go back and look at the experiment. I kind of didn't do much with it after the first part here. But what they're supposed to do is observe the shapes of the graph, the points on the graph, and kind of think about it a bit. And then they go do the absorbance and they look at that one. And then this is where you know, a little different from the College Board version because the kids actually develop this relationship based on some suggestions, because why would they know otherwise? So we're looking at it and saying, well, look at these two relationships, and you can see that one is kind of simple and one is not so simple, and then go look at your graphs. And so, you know, what's the relationship between the two of them? And so what we're going to do is I just wanted to show you a couple of things as far as how do kids create a report. You know, if they want to create a report and they want to put both of these into the report, how would they do that? And one easy way to do it is just take a screenshot and then drop that into whatever you're using. But there's a kind of a nice tool that's built into our software. It's not horrible. And so I'm going to go and I'm going to get a PNG file. I forget. I always forget what those acronym, printers, native graphic or something like that. And so this is built into the software. And what's kind of nice is there's a copy button as well as save button. And so the last 3 years I taught, I was teaching forensic science, and they allowed me to, I'm going to move this box because I want it up a little higher. They allowed me to do it, but they gave me no money. So it was like, yeah, Noosh, you can teach it. I wrote the curriculum for it, which was kind of fun to do. But I had no money, no books, no nothing. We were a Google school. Yeah, it's still not wonderful, but that's not bad. So what we were doing was I was having the kids create more and more electronic reports. And one of the nicest ones that I found was Slides. Slides makes really nice reports, and this little template that I use with my younger kids, my older students didn't need it, but you can use any electronic device and then write out a graphical, pardon me, out a spectral or graphical. You can copy your graph and you can put it in. Where's my graphs? They're here somewhere. There we go. You can just drop them in there, and then let me get the other one. So let me go look at the other one. So let's see. I already saved this one. By the way, you Excel people and Sheets people. You can also create CSVs if you really want to. Let me go open A and put it side by side. I don't know if that really matters, but let's go get A. So A is there, right? So I'm going to put them side by side. Maybe. There we go. Not super linear, right? I mean, you could, it's kind of up to the students how they want to present this to you in the report. They could put just to emphasize the point that it's definitely not horribly linear, but we can also go grab that. And what happens is the question is asking them to compare them. And so when they write their report, this might be a nice way to have them both on the screen in their report, and so they can actually compare the two graphs and say, well, let's take a look at these two, and you can see that the absorbance versus concentration is much more linear, more convenient to do the calculations than the transmittance. And then, what was the point of the experiment? Let me go back and get the absorbance graph again. So let me get rid of this and let's go get the absorbance graph. And so the whole point of this was to determine the concentration of the food dye in the sports drink. And we do have folks, do I have spectrometer disconnected? Oh, it's there. Okay, there we go. We do have folks that get a little confused about this. So these are unknowns, right? We don't know the concentration, so we don't collect data for these. What we do is we simply measure the absorbance. So we decided absorbance versus concentration is linear, and it'll be easier to do the analysis. So let me get a sample of whatever this stuff is, which I don't care for these, but I think probably a lot of your students do. And so this Gatorade, is that what that is? Put that in there. And so this number right here, that's live. That is the sample that I just put into the spectrometer. How can you get the concentration from that? Well, two ways. The right way and the cheater's way. The right way would be that this is the value of y. So if we look at the linear regression equation, y equals mx plus b, that number is that value. So you would just simply put that in the equation. M is the slope, b is the y-intercept, and solve for x, which is the concentration. College board, probably most college teachers would probably want their students to do it that way. There is a way which you can decide if you tell your students about this or not. It built into our software where you can interpolate the answer. So under the graph options menu, you can choose interpolate, and you can then, that will take you between points. And so then what the students can do is they can go to the absorbance value, 1.18. Getting close. See, this is the problem is, you're limited on pixels and stuff like that. So it's telling me it's 1.46 times 10 to the minus 6 molar, okay? Not one nice thing about the software too is if you're doing more than one thing like that, you could add an annotation. So you could say G drink absorbance is 0.180. And so, and then you can, let's go put the other one in. So once again, I should rinse the cuvette, but to save time, and I want to give Melissa a few minutes, let's go get the other one. And so, kind of wanted, I don't know how many people realize that there is a annotation option. There's a lot of things in the new software that, especially folks that have been used to using Logger Pro, wanted, and they're there very frequently, but they're just not as obvious because for whatever reason. So anyway, this one does look a little darker, so let's see what that looks like absorbance-wise. So there is oh yeah, definitely darker. So what you might do is put a little annotation in there and say, what is that stuff? Power aid? Absorbance is 0.536. And so then, you've got a record of the absorbance values, which you could later use to do the calculations. So thoughts, questions, concerns? Melissa, what do you think?
It's looking good. We had lots of questions coming in.
Anything I can address, or I bet you've already got it all covered?
Yeah, most of them were pretty straightforward. People were asking about other types of beverages that you could use to do similar analysis.
I don't see any reason why you couldn't do things like apple juice and stuff like that. It's just what's causing the color is not quite as obvious if you do that. The other thing you have to think about is the turbidity of the solution. I don't know if orange juice would be an appropriate one to use, or milk or something like that. I had a teacher ask about milk the other day, and it's going to bounce the light all over the place. So these sports drinks or anything that's using artificial sweeteners, I think you're going to get good results from. So Powerade and stuff like that, I'm sure would work. Melissa's done some stuff with some of these drinks that have fluorescing dyes in them, and you can actually measure the fluorescence spectroscopy from some of those. What is that dye, Melissa?
The energy drinks, they have vitamin B.
Yeah, right. So riboflavin.
Yeah, riboflavin.
Yeah, they
in them.
fluoresce, and not super great in the SpectroVis. I mean, you can see something, but some of our other spectrophotometers, you can adjust the excitation wavelength a little bit more easily, and so you can look at the fluorescence of those. So. Anything else? Bottled lemonade, maybe Kool-Aid. There you go. Kool-Aid is, depending on the flavor. I have a food experiment I wrote where you separate blue and red from the grape Kool-Aid, and you do this. You do the spectra. You just measure the spectra, because there's two blues and there's two reds, and so you can actually determine which blue and which red are in the grape Kool-Aid. But yeah, there's no reason why you couldn't do other flavors. I think that would be kind of fun for the kids to bring in their favorite flavor of Kool-Aid or something. So Melissa, I'm going to give you the rest of the time.
Yeah. Okay. Right. So, first off, there are more green chemistry resources from Vernier. So if you're trying to just um, meet different green chemistry standards that I know are popping up across states and different programs, we do have resources for you. There is a website that you can go to that has all of those first 5 experiments downloadable for free, including the one that Noose just walked you through. We also have done webinars on some of them, including the titration one, the electrochemical series one, and Avogadro's number. And then recently, so it's not in those 5 experiments, we have a brand new one that came out. And the full write-ups just came out a couple months ago about why did my tea turn purple? And so that's also using the spectrometer, and it's looking at tea, so it's also looking at beverages. Um, but it also uses pH to measure equilibrium. And so you can help your students look at equilibrium.
Oh, I forgot. I can't do
I was like, I'm
it.
using the, I was like, are
Gonna
you
get a web
gonna
page.
help us by throwing up
So
some
sorry.
info?
I'm sorry, bitchy. Yeah, sorry. I'm sorry.
You're totally fine. But all those are links in there, so definitely go to the resources folder and get all those links. And then if you are interested in even still more, we do have a partnership with Beyond Benign. So Noose, if you go to the next slide. And they are a great resource for green chemistry experiments. They have a fantastic green chemistry teaching and learning community that basically is a way for educators to share experiments and ideas, things they're learning in the classroom with each other. So I highly recommend checking that out. But in particular, right now, Vernier and Beyond Benign are doing a call for papers. If you already have, it sounds like a bunch of you already have some great Vernier experiments that are green and have green chemistry components in them. If you want to get your experiments published, get a DOI, get publishing credit for your professional growth, career advancement, all kinds of things. Definitely submitting to the GCTLC and this call for papers would be a fantastic opportunity. We're doing it through November 30th. Click through the links there. We also put in the folder a guide to submitting your resources to the GCTLC. So highly recommend, definitely reach out if you have any questions or have any, just great suggestions that you want help with, because it sounds like all of you have amazing suggestions and experiment ideas that could go directly into this call for papers. So highly recommend. And that being said, I think we have a giveaway next.
So, Dylan, you still there? Did I,
Absolutely.
did I bore you?
No way.
All right. So Dylan's gonna figure out who won the $100 gift certificate.
Yes. So as Noose and Melissa were chatting with you all, I went ahead and put everyone's names into a random name generator to select today's winner. And the winner is Christy W. So congratulations, Christy. You are the winner of a $100 gift certificate to Vernier. I am going to email you just after this webinar to get some information about how to get that to you. So keep an eye out for an email from someone with the domain at vernier.com. If you don't see it in your inbox, check your spam. And congratulations.
Hey, folks, please don't get stuck. I we are here, Melissa and I, we put a fair amount of time in, but the whole point is if you need help, don't get stuck. You can chat with us. I chatted with a woman for better part of an hour today on an experiment with dissolved oxygen. You can email us, and of course, love to talk on the phone. So if you want to just call us, that would be great. But don't spend more than I'd say 20 minutes on something. And this Vernier stuff sucks. I can't figure it out. Don't do that. Give us a call. Let us know how we can help. Okay. So I, well, I actually managed to cut a little. How did I do that, Dylan?
It was
That's,
the power of back to school news.
it must be because these folks, they have a lot to do. So okay. Well, unless you can think of a reason why I should belabor this any longer, I think we should maybe call it good.
All right. Well, thank you all so much for coming. Noose, Melissa, amazing presentation. Thank you so much for walking us through all of that. Thank you all for attending, and we hope we'll see you at our next webinar. Have a great rest of your day, everyone. Bye, all.